Hello my dear friends, welcome to our YouTube channel ATC Max. In this class I pick one problem, this f of x, and with the help of that function I am going to deduce one new infinite series. I am going to deduce something is interesting, some new infinite series. For example, let's see that 1 by 1 squared plus 1 by 2 squared plus 1 by 3 squared plus 1 by 4 squared, etc. etc. So what is the sum of this infinite series? We don't know. Yeah, let's find out this one. And even this series can be written in a simple form. It's nothing but summation n is equal to 1 to infinity 1 by n squared. Yeah, it may read like this. By putting n equal to 1, 1 by 1 squared. Putting n equal to 2, we get 1 by 2 squared. By putting n equal to 3, I am doing 1 by 3 squared, 1 by 4 squared, like that. Suppose if I am having 1 by 1 squared plus 1 by 3 squared plus 1 by 5 squared, etc. etc. That means only the odd values in the denominator with the square term. What we can write? We can write this by summation n equal to 1 to infinity 1 by 2n minus 1 whole square. So both are same. By putting n equal to 1, we get 2 minus 1 is 1, so 1 squared. By putting n equal to 2, 4 minus 1 is 3 squared. N equal to 3, we get 3 into 2, 6 minus 1, 5 squared. So this indicates the odd values, this indicates all the numbers. Right? Suppose when we have plus minus, what we can do? We can add in the numerator minus 1 whole power unit. That's it. Okay? So these types of series, can be able to get these series? Yeah, we can get these values, the sum of these types of interesting infinite series with the help of the Fourier series expansion ideas. So that is a main application of the Fourier series expansions. So in this video, I am going to express f of x is equal to x into 2 pi minus x in the interval 0 comma 2 pi. After expansion of this, I am going to find the first series. What is that? Sigma n is equal to 1 to infinity 1 by n square. That means that 1 by 1 squared, 1 by 2 squared plus 1 by 3 squared plus etc. What will be the sum of the infinite series? 1 by 1 squared plus 1 by 2 squared plus 1 by 3 squared, etc. etc. Okay? Can I go to the sum? So as we already know that the required Fourier series for the interval 0 comma 2 pi is y is equal to f of x is equal to a naught by 2 plus sigma n equal to 1 to infinity a n cos nx plus b n sin nx. Is right? So this is my required Fourier series expansion. I need to get the a naught, a n as well as b n. So there are three constants. In each Fourier series there are three constants we need to find. So we need to go for the first one, a naught. The a naught formula is, what's the a naught formula? This is 1 by pi integral 0 to 2 pi f of x dx. Is right? Is equal to 1 by pi. What is my f of x here? It is x into 2 pi minus x into cos nx dx, because cos nx no, it is a naught only no, so it is f of x alone is equal to 1 by pi, this is nothing but 2 pi into x, so integral 0 to 2 pi x minus x into x square and dx. So integrate this with respect to x, 2 pi into x squared by 2 minus x squared integration is x cubed by 3 with the limit 0 to 2 pi. So here 2 will cancel, right? So let us substitute the limits. So a naught is equal to 1 by pi. If you substitute x equal to 2 pi here, 2 pi square is 4 pi square. So 4 pi square into pi is 4 pi cube. Okay? Minus x power 3. So 2 pi whole power 3. What's 2 pi whole power 3? 8 pi cube by this 3. So this 3. Let us take the 3 as LCM. So 1 by pi. 3 means 3 4s are 12. So 12 pi cube minus 8 pi cube. So 12 minus 8 is 4, 4 pi cube. After cancellation of 1 pi, I am getting that 4 pi squared by 3. So this is my A naught value. From this, what about the A naught by 2? Because I need A naught by 2 value. So let us divide by 2, we get it is 2 pi squared by 3. So A naught by 2, we got 2 pi squared by 3. So the next one is AN. How to get the AN value? Yeah, let's go for the AN. Go for the AN. AN formula is 1 by pi integral 0 to 2 pi f of x cos nx dx. Why we add cos nx here? Because the coefficient of cos nx is AN. So that's why to get the AN, we use the cos nx. Isn't it? We use the cos nx. Now this is looks like the Bernoulli model. Understand? So 1 by pi integral 0 to 2 pi. What's f of x? Yeah, it is x into 2 pi minus x. Otherwise 2 pi x minus x into x is x squared into cos nx. This is looks like the Bernoulli formula model. This is the u, this is my v. So let us use the Bernoulli concept. 1 by pi u v1 sin nx by n minus comma minus differentiation of 2 pi x minus x square is 2 pi minus 2x differentiation. Integration of sin minus cos nx by n square. Sir, differentiation, integration, formula plus, plus, minus, plus. Again differentiate this with respect to x. We get my 2 pi is a constant on 0. Minus 2x becomes minus 2. Correct? And cos nx integration is plus sin nx. So minus as it is retained. Minus sin nx by n cube. The third time integration. Close the limit 0 to 2 pi. Right? Before going to apply the limits, I think so there are 1, 2, 3 terms, very lengthy one. So before going to apply the limits, what I suggest you there always, by putting x equal to 2 pi in the sin nx, I am getting that sin 2n pi, it is 0. Sin 0 is also 0. Similarly, by putting x equal to 2 pi, we get cos 2n pi, it is plus 1. By putting x equal to 0, we get cos 0 is 1. So after knowing these things, I feel that sin nx term is 0 for both the upper and lower limits, and this is also sin nx. So we don't bother about this first and the third term. We simply omit those things. So let's focus on the middle one. Middle one is minus minus plus, right? 2 pi minus 2x. So 2 taken outside. 1 by n square is also taken outside. So already we have 1 by pi here. So minus to minus plus 2 taken outside. Then 2 by n square. So 2 by n squared of the balance is pi minus x into cos nx with the limit 0 to 2 pi is equal to 2 by pi n squared into. Now substitute x equal to 2 pi here. X equal to 2 pi here. What is pi minus 2 pi? Minus pi. What about cos 2n pi value? Plus 1. Minus. By putting x equal to 0, pi. Pi minus 0 is pi. Cos 0 is 1. So minus pi is minus 2 pi. Minus 2 pi into 2 is minus 4 pi by pi n squared. After cancelling the pi, I am getting that minus 4 by n squared is my AN. Minus 4 by n squared is my AN. Is it clear? Is right? So we found A naught, then AN. Now finally, so I got the A naught value, AN value. Now finally we go for the BN value as well. What is the BN? What's the BN now? Yeah, BN is nothing but the coefficient of sin n, isn't it? So this is a slight change in the formula. This is slight change in the formula. So how to get the BN? So BN is equal to 1 by pi integral 0 to 2 pi f of x sin nx dx. So this time sin nx. It's clear? Right? So 1 by pi integral 0 to 2 pi x minus x squared, that is my given f of x sin nx dx. Right? Now apply the Bernoulli formula. Apply the Bernoulli formula in this step. In this step, uv. So Bn is equal to 1 by pi u 2 pi x minus x square into sin nx integration is minus cos nx by n. Minus, formula minus 2 pi x minus x square differentiation is 2 pi minus 2x. Cos nx integration is plus sin nx, but minus already there. One more n, so n squared, the denominator. Once again differentiate this, we get minus 2x. Minus 2x becomes minus 2. Minus 2x becomes minus 2. And sin nx integration is minus cos, minus of minus, plus cos nx by n cube. With the limit 0 to 2 pi. Once again use the sin 2n pi value, sin 0 value, cos 2n pi value, cos 0 value. There are only one sin term, so the middle one, now this becomes 0. Got it? Apart from that, 1 and 3, there are two terms are there. 2 pi x minus squared minus cos nx by n. This is minus 2 cos nx by n cube. I think minus sign is common. Can I take for my convenience the minus sign also? So the balance is this and the third one. The substitute x equal to 2 pi karna. Substitute x equal to 2 pi. 2 pi into 2 pi becomes 4 pi squared. Is right? Substitute x equal to 2 pi. 2 pi whole square is equal to 4 pi square. So upper limit is same, lower limit is also same, so it becomes 0. 0, nothing, 0. Oh. Similarly for x equal to 0, 0 minus 0 is 0. So anything into 0 is 0. So unfortunately the first term becomes completely 0. Even though it is cosine term, due to the limit value it becomes 0. So we also omit this term as well now. So what is the last one? Minus 2 cos nx by n cube. This is the only term. So when I take the minus 2 by n cube outside, let us substitute in the place of x equal to 2 pi, we get cos 2n pi value. What's the cos 2n pi value? Plus 1. By putting x equal to 0, we get cos 0. So cos 2n pi value is 1. Cos 0 is also 1. So what's the 1 minus 1? 0. 0 and nothing is 0. So Bn is equal to 0. So maximum we will get the answer within the fourth step. See that? First step is the Bernoulli formula, second step, third step, maximum. If you are going to have some more additional terms, we can proceed for one more step. But this is possible only when if you are familiar with the Bernoulli formula and some basic results. Got it? Now I found A0 value, AN value, minus 4 by n squared, but Bn value is 0. Now substitute A0. What's the A0 value? I think so. A0 by 2 is equal to 2 pi squared by 3. Isn't it? AN value is minus 4 by n squared. Bn value is 0. Now substitute these three values in the given equation number 1. Given equation number 1. So I am getting that the Fourier series y equal to f of x A0 by 2. 2 pi squared by 3 plus sigma n is equal to 1 to infinity. What about an, sir? An is minus 4. So minus 4 by n square into cos nx. What about Bn? Bn is 0. So just middle. So this is my required Fourier series expansion. Clear? Now my question is, I am going to extend this Fourier series to get the value of this infinite series. Once again, can you look into the denominator of the given infinite series? Square terms are there. Square terms. 1 square, 2 square, 3 square, etc. All are positive signs. All are positive signs. Clear? Now my function is defined in the interval 0, 2 pi, and both are the point of discontinuity 0 and 2 pi. And the function is 2 pi x minus x square. Is right? And there are some possible values of x we can choose within this interval. The one is cos 0 is 1. Second one is cos pi by 2 is 0. Cos pi is minus 1. Yeah, cos 2 pi is also plus 1. Cos 3 pi by 2, you can go for cos 3 by beta as well, no problem, because cos 3 pi by 2 is 0. Okay, so if it is 0 means don't use this value, because when you choose x equal to pi by 2, this becomes 0. We won't be able to generate this series, because this series can be generated with the help of x value. That is the n values, right? So n value. What is the n value here? 1 to infinity. So this term only will generate this series. So we want to retain this term. So what I am going to do that, I am going to take x is equal to 0 as a simple case. X is equal to 0 is a point of discontinuity. Is a point of discontinuity. Is a point of discontinuity, and also it is in the extreme side, right sir? It is also in the extreme side. So by using the convergence theorem, what is the value of f of x at x equal to 0? What is the value of f of x at x equal to 0? This already you know, this is the periodic function. So once it's a point of discontinuity at the extreme side, take the average of both the endpoint values. So f of 0 plus f of 2 pi by 2. Now substitute x equal to 0, this will use 0. Substitute x equal to 2 pi. 2 pi into 2 pi is 4 pi squared minus 2 pi whole squared, it is 4 pi squared. So it is also 0 by 2. So the left hand side is simply 0. Now equation 2 becomes now, left hand side is f of x and x is equal to 0. Right hand side 2 pi squared by 3 is right, plus minus 4. You are going to take the minus 4 outside. Sigma n equal to 1 to infinity cos 0. What is the cos 0 value? 1 by n square. So this is actually my requirement. So almost we reach the final answer. Do some slight modifications, we will get the answer. Let us see that. What about the left hand side value? As we know, it is 0 with the help of the convergence theorem. So left hand side 0, then 2 pi squared by 3. This bring to the left hand side, becomes minus 2 pi squared by 3 is equal to minus 4 times sigma n equal to 1 to infinity 1 by n square. So this is my requirement. Fix this one side, others can be simplified in the other cases. There is the other side. So can I cross the minus sign here? Then this 2 comes down. What we will get? We get sigma 1 by n squared is equal to, once I repeat this, sigma 1 by n squared is equal to, this minus 4, go to that side, denominator, minus minus will cancel, 2 by 4 is 1 by 2, so we get it is 2 pi squared by 3 is already there, into 1 by 4, after cancellation of 2, this will give pi squared by 6. So sigma n equal to 1 to infinity 1 by n squared is equal to pi squared by 6 is the answer. When you substitute n equal to 1, we get 1 by 1 squared. N equal to 2, we get 1 by 2 squared. N equal to 3, we get 1 by 3 squared, etc. up to infinity. So this is the my required sum of the given infinite series. But that infinite series can be generated after getting the Fourier series. After getting the Fourier series, look into the terms where we need to generate the square. I think this cosine term only. So let us retain this cosine term. When we retain the cosine terms, probably the possible value for x is 0 or pi or 2 pi. But I need only the positive series, that's why I choose x equal to 0. Some of you may have the question in your mind, can you choose 2 pi sir? Yeah, go for it, because what about cos 2 pi value? It's also plus 1. It will generate on the positive series. So when we get the plus minus, it may be the question. When we get the plus minus, when we get the plus minus in the cosine, under the cosine sign, multiples of pi will get plus sign, minus sign. Suppose the question was plus 1 minus 1 by 2 square plus 1 by 3 square. So that time you can choose x equal to pi. You may get this series. It may generate this series. So this is the idea behind this concept. Thank you for watching our YouTube channel. Please subscribe, share, as well as comment our YouTube channel ADC Max. Thank you so much.